capital gains tax.
This is the second in a series of 2 videos on public sector analysis. So in this one, we're going to look at how to compare alternatives, which is to say if you have multiple options in a public sector decision, how do you go about making it? This is going to assume that you've gone through the first one, so you're already very familiar with knowing what's a benefit, disbenefit, and a cost, and then how to translate that into a cost-benefit ratio. It also makes the assumption that you know that if that cost-benefit ratio is greater than 1, then that's a viable option. So now we're going to look at examples of multiple options that are viable. But here I put down the steps so that you can, nice looking highlight, so you can see the steps that are necessary in order to solve the problem. First is you compare your option, like we're doing here, versus do nothing. And if each one of those proves to be a good option, then you go about comparing the options against each other. So in this case, you can see this table, we have design 1 and design 2 for modifications to a county hospital. Right. So we're going to evaluate it at 5% for 30 years. Now, sorry, this assumes that you also know how to convert everything. So in this case, we chose to do it in annual worth. So we're converting the annual worth of the costs, right? So here's the cost, here's the building maintenance cost, and then we calculate the BC ratio, which is the standard, not the modified. And if you don't know what I'm talking about, definitely watch video 1. So then we go through and we find the ratio for the first option is greater than 1, and the ratio for the second option is greater than 1. So both of these are viable options. It would not be correct to just automatically say, well, option 1 has a larger BC ratio than option 2 does, therefore I choose that, moving on. Because there are scenarios and situations in which an option may have a larger BC, benefit to cost ratio, but when compared to another alternative with a lower, it turns out that the lower ends up winning. What I mean by that is we're going to come here and compare. And notice in the steps here, it says that we're going to take the largest option, and that will be the defender. And that's going to be competed against the next largest as far as costs go. Now in this one, it's pretty simple because we only have 2 designs, right? So design 1 has the larger upfront cost, 15 million bucks. So it's going to be the defender. And design 2 is the lower, next largest cost, 10 million. So it's going to be 2 versus 1. So that's why we have here 2 versus 1. So this is the magic equation, which is delta V minus delta D divided by delta C, which is to say the benefits minus the disbenefits divided by the cost. Only in this case, option to option. So you take the cost of option 1 and subtract out, right, the cost for, you take the cost for option 2 and subtract off the cost for option 1. That's why I put here delta B of 2 to 1, right? So this is 2, this is 1, and we get $250,000. Now we're going to look at costs. So we take the cost of option 2, which we calculated over here, and subtract out the cost of option 1, which is calculated here, and we get 345. So the ratio between those is 0.72. So you will note that is less than 1. Since this is less than 1, right, then we choose option 1. So option 1 is selected. If that had been greater than 1, then option 2 would have been selected. So whenever you're doing the delta BC, if the delta BC is greater than 1, then the defender wins, right? If, and here it is, I'll put that in red. If the delta BC is greater than 1, then the defender wins and moves on to face the next challenger. In this case, there is no next challenger. If there's no next challenger, so that's it. We choose option 1 and we move on. Now I threw this in there. Let's say we have some new information. So design 1 will result in an unrealized loss of 0.5 million bucks a year. Design 2 will result in an unrealized loss of 0.4 million per year. Now it says unrealized, so when we're talking about an unrealized loss, we're talking about a disbenefit, right? Like let's say, like in the video 1, we're dealing with a property and we decide not to develop it. So we don't develop it, then we miss out on tax revenue. But that tax revenue doesn't come out of our bank account, it's just never realized. So it's a disbenefit. So here we have 2 disbenefits. Right? These represent disbenefits. So now we go back to our equation. This time we're going to calculate and add in the delta D, right? The difference in disbenefits. So that comes out to minus 100. Right? Because if we come back here, we have 2 versus 1. So the larger of the 2 ends up being here, which is why we get a negative value. So you have a negative and a negative, so that's going to end up being added into the equation. And now we get 1.01, wouldn't you know it? So that means design 2 in this case is selected, because now the delta BC, right, is greater than 1. So that means the defender remains, the defender wins. So in this case, even though it may have a smaller, even with these considered, it does win out. So we would choose design 2. Now I found this beauty on the intranets. So I found this out on the web. It's a good slide, but it seems to have an issue. So let's see what that issue is. So we have 3 alternate designs that we're comparing. It looks like it's some kind of electrical design, as this seems to be kilowatts. So they've already calculated for us the annual worth of the investment. So generally speaking, when we're talking about this investment, that's a first cost. Right? So this I is generally first cost, and they already converted it to annual for us, using A given P in whatever method they chose. And then the operations and maintenance are given to us annually, and then the annual benefit. So they presumably already did the individual options versus do nothing, because the next step they show is an incremental analysis. So let's give them the benefit of the doubt that each one of these do nothings is losing out. So they compared option D versus do nothing, and it won out. Option C, B, A. So all these are viable. Now what do? Now we compare the largest of the costs to the next largest. So we're going to compare D versus C, and then see who wins. And then whoever wins is going to face the next largest cost. The next largest cost will be B, and whoever wins that will then go against A. All right. So let's go back to the first one, which is D versus C. D being the higher cost. So they calculate out 0.87. So since this is less than 1, then that means D is eliminated and the challenger wins. So C moves on as the new defender. As we figured out here, whoever won this, in this case C, is going to go against B, because B is the next highest cost. So they do an incremental analysis here, and they show a delta BC of 1.3 and a modified of 1.36. Now, if this were the case, this is greater than 1. So what happens in this case? If it's greater than 1, then C moves on, because C is the defender. So but when we go over to here, their slide shows B versus A. So something's wrong. So I went and threw this in my calculator. Right? And so let's look at this. You can see the C versus B, right? Here's the cost of C, which is 1 million. So here's that. And then 985,550. Here's that. So there's my delta B. Here's my delta C. And I get a cost benefit ratio of 0.39. So that's less than 1. So if that's less than 1, I'm going to switch to red, right? So this is what I think is the correct BC ratio. If that's the correct BC ratio, that means that B wins, not C. And then that would jive with the slide because now it's B versus A. So my goal for this video is to use every color in my palette. So now we have B versus A. And presumably this is, because this is correct, I checked this BC. So if this is the correct BC for B versus A, then that's much greater than 1. So that means what? That means the winner of this is B. So B wins. So in the end, you would select option B. That same slide deck had this one. So they show an accident barrier. So this is kind of an interesting problem. So they're looking at 3 different ways to help with accidents on presumably highways or roads or whatever. One is concrete barrier, one is wire mesh barrier, and the other is a landscape or median barrier. You can see that each of these comes with a different benefit, right? Annual reduction, you'll note in this chart, so here's the investment, which is a first cost. Here's the annual maintenance costs, and then they have annual reduction in accidents. So it's not explicit in here benefits, but the benefit is this annual reduction in accidents, right? And is the benefit to society, right? You're helping reduce accidents. And the cost effectiveness per accident. So when there is an accident, this is the savings that you're getting per accident. So the way to monetize that benefit is to compare this to this and this to this, right? So we're going to, if we use a concrete barrier, reduce accidents by this amount by that amount, right? And just multiply that out, and that's going to be the annual benefit in dollars. So this one didn't have a solution, and so I calculated it out. How do we do that? Well, we identify what goes first. So who's first? The most expensive cost is first. So here's the most expensive cost, the concrete barrier. Next most expensive is the wire mesh barrier. So it's going to be CB versus WMB. And that's where I start here. So you can see first up, and this is what I plugged into my calculator. There's the benefit of CB, right, the concrete barrier, which is 2127 times 85. And that gives me my annual benefit. When it comes to my benefit of the wire mesh barrier, same thing, 1943 by 63. Now let's look at the cost. The cost for CB, I took their word for it. So I took their word for it that it's 180,816. But like the previous slide, this slide also has an error. And that is that they did the total annualized cost for us, which was nice of them. But here they show A, so they took A, which is first cost, and they show P given A 6% for 10 years, which is, the last part of that is fine with me, right? So 6%, 10 years, okay, so now I know they're evaluating money at 6%, and they plan on these barriers being compared on a 10-year time frame, no problem. The problem is this P given A, right? So here, they're taking part A. This investment is a present worth, right? This is a present worth, and they're saying P given A. So this really should be present worth, and I'm looking for a given P at 6% for 10 years. So let's say they did get this correct, right? So I entered that in as my cost for the concrete barrier, and then I entered that in for my cost for the wire mesh barrier. And then just throw that into the delta BC, right? So this is the concrete barrier, which is the more expensive, minus the mesh barrier for the benefits. And then you've got the costs for the concrete barrier minus the costs for the wire mesh barrier. And I get 0.999. So technically, right? So technically that's less than 1. So if that's less than 1, then what do we do? If that's less than 1, then we would select the challenger. Then the challenger moves on. So why is the challenger not reflected here? Because if this were me, and if the budget would allow it, being that it's essentially 1, right? I mean, we're basically talking about 1 here. 0.999, right? I would argue that we should move forward with the option that offers the greatest benefit to society. So if we were comparing these two, this one's only going to stop 63, this one is 85. This one saves more per accident than this one. This one offers the greater benefit. So considering this is essentially 1 in our cost benefit, I would try to argue that this should go on to compete with the landscape barrier. I, in this mythical world, won that argument and move on. So concrete barrier versus, so now the concrete barrier versus the landscape barrier. We'll use pink. So now it's this one versus this one, right? This is the higher cost, so it goes first. So it's CB versus LMB. Through the benefits and the costs for the land barrier into my calculator, and then just retabulated the delta BC, and it came out to 0.999. So then I realized they're just messing with me, in this slide. So I would try to make the same argument again, that look, this offers twice the benefit of this one, and therefore we should go with CB. Now, if budget is really tight, I mean, this wouldn't be an option if you didn't already have at least this amount of money to install it, but you could make the argument that this is half. This is half of this, right? And yet, according to this, they're essentially comparable. So you could use the other $500,000 to go do other things, and therefore this should be chosen, and that would be reasonable. But what I hope you're getting out of this is the way in which you do delta BC, right? Which is you identify the highest cost, compare it to the next highest cost. If it's greater than 1, then the defender wins. If it's less than 1, the challenger wins, and then you move on to the next option, the next highest cost option. So if I had, for the sake of argument, a guy with a sign, right? And that cost us $30,000. Well, actually it cost us $3,000 to buy signs, right? And then 30 grand to pay some guy to stand there with a sign saying, "Don't crash." Right? And that is helpful in reducing 20. And the reduction in costs is like $10, right? So in this case, we would compare the winner, whichever you argued, right? The one with greater benefit or the one that's a lesser cost. Or if you're a real stickler for rules, this is less than 1, right? Whichever goes on to then face the lowest cost item, right? And that's how you compare options in public sector projects.